Okay, let's get started. So hopefully you are here to learn about OpenTelemetry. This talk is going to be a high-level overview of the why of OpenTelemetry and the what of OpenTelemetry. We're not going to do the how. I'm not going to go through code examples of exactly how you use OpenTelemetry. I have tons of talks that are recorded on YouTube that you can go and have a look at for that, or come see me at another conference because I will do those as well. But really, we're going to talk about the why and the how. So speaking of the why, this is the origins of observability. So way back 1500 BC, some project manager went to some caveman and says, can you just carve our performance stats into the cave wall, please? Sort of really nervous about the time when he's going to ask, can you put auto refresh in, please? I mean, I jest, but what I mean by that is observability isn't new, and observability is the why of OpenTelemetry. Really, the OG is this. It's the blinky lights. Now, I do need to ask, does everybody know what these are? I found out recently that there are people who have never seen one of these in real life. These are called servers. There's lots of them in the cloud. But obviously, that was the idea. The OG of observability, to understand whether things were running, the OG of monitoring was these blinky lights at the end of your office. If the lights were going fast, we were making money. If they were going slow, we weren't making as much money. If the lights weren't on, then we called somebody to come and fix it. That was how it worked. It was easy. Okay, so my name is Martin Thwaites. I am first and foremost an observability evangelist. Some might say activist. Depends on what day of the week it is. I am also a developer advocate for a company called Honeycomb. We develop a backend for OpenTelemetry data that allows you to be able to investigate. I'm also a Microsoft MVP. I'm sorry for the Java people in the room. .NET's way better. If you would like to listen to what's coming up in the OpenTelemetry and observability space, you can follow me on social media, Blue Sky, Mastodon, LinkedIn. I'm Martin.net everywhere. But follow me. If you want to, for this token sort of British snark on top, you have been warned. So, right, I'm going to take you back to something that is probably a little bit more understandable for newer people in the room. Around the sort of 2000s, we had metrics. Metrics ruled the world, and they ruled the world because of two reasons. Because storage was expensive. My first hard drive was 70 megabytes. That probably dates me a little bit. Now, this isn't a challenge. I am massively sure there are people in the room who can outdo me with that. But ultimately, no judgment. but ultimately, we couldn't store lots of data. We had to summarize data early on in the pipelines to be able to store more data. But also, our systems were simpler. Our systems were essentially like a box line cylinder. Our architecture diagrams looked like this. You had your users accessing your system. Maybe you had a load balancer, I don't know, an F5, something like that. And then you had a couple of machines that ran your application, and there was a database. It was easy. So we had metric systems. We had systems like this. Anybody know or have used either of these two systems? This isn't a drinking game. We're not going to be doing shots if you've used it. There we go. Okay. So what we've got is CACT on one side and MRTG on the other side. These were tools that we could use to visualize metrics, but there wasn't a lot of different dimensions that we would use. There weren't a lot of servers that we'd use. We didn't have things like auto-scaling. The best idea of auto-scaling was when your local computer shop had a sale and you went down there and said, oh, I'll get this other machine, and then you'd add that to your thing. And it'd take like 3 weeks to auto-scale your system. So we had these kind of ideas of just small dashboards using this metric data with very few dimensions in there. Now, fast forward a little bit onto sort of 2012, 2013, our systems started getting more complex. We started to move into the cloud. We started to have this idea of auto-scaling and that kind of stuff. And we built tools called time series databases, which were databases to be able to store all of this metric type data, these time series aggregates at scale. And we still have the two tools that were prominent at the time today, which is InfluxDB and Prometheus, the two primary tools that you would use for this kind of data. InfluxDB, where you push your metrics, and Prometheus, where you primarily have it scrape your metrics. But these were really important tools to be able to show and store this stuff at scale. And around that time, we also had a tool called Logstash, one of my favorite tools, for two reasons. Firstly, it does exactly what it says on the tin. It's a tool that allows you to stash your logs somewhere. But number two, the logo looks exactly like the name. It's a log with a mustache. I do believe we have lost our whimsy when it comes to naming tools these days. Because back then it was the name of the tool was irrelevant. It was the functionality of the tool. But nowadays we reach for really advanced, like Thanos. Like what does Thanos do? I mean, I know what Thanos does. I know what Thanos does, okay? But we come up with these abstract names. I love Logstash. Now, Logstash was part of a stack called ELK, which was Elasticsearch, Logstash, and Kibana. And this was the start of this idea that we had this kind of analysis flow where we would take these logs, these textual records of data, and we'll come on to definitions of logs in a little bit. But we'd take these and would generate structure, would generate formats, and we'd extract data and give it properties that allowed us to be able to graph data. This is a newer version of Kibana. It did not look like this. It was not this pretty when I started using it. But it was this idea that we could start to query our log data. It wasn't just we were looking at a linear flow of log data anymore. We could start to query this at scale. And then we move a little bit further to sort of 2017, sort of modern day observability, the sort of start of what we start to think now about observability. So around that sort of time, we had this idea of systems getting more complex. We're now into microservice worlds. We're now at a few years later was when Monzo produced their diagram of their 1,500 different microservices. And every developer looked at it and just went, no, you seem proud. You did a bad. But we had all these ideas of how a transaction in a system would span multiple different services. And we had this idea of distributed tracing. And at the time, we had two tools. We had a tool called OpenTracing, and we had a tool called OpenCensus. And inside of your organization, you choose one of these tools. They would interop quite well together. You'd probably use something like Zipkin or Jaeger as a backend to be able to send this data to. But the problem was, as your systems got bigger and you brought new engineers on, as we always do, the new engineer comes, OpenTracing. No, you should be using OpenCensus. Or if you're using OpenCensus, you hire someone, it's OpenTracing, you should be using OpenTracing. And you could never use both of them together. So some incredibly intelligent people came together and said, wow, well, what we've got is we've got two competing standards. And the obvious solution to that is, well, what we need is one standard to rule both of these two standards. And we all know where that ends up. However, OpenTelemetry is the exception. Because about 2 years ago, both OpenTracing and OpenCensus deprecated themselves in favor of OpenTelemetry. So nowadays, there isn't OpenCensus and OpenTracing. We have bridges in OpenTelemetry for people who are using those tools. But ultimately, there is only one tool now, which is OpenTelemetry. So that's kind of the sort of why of where we got to with OpenTelemetry. There's a ton more in the history stuff. I have talks on past, present, and future for that sort of stuff. So what exactly is OpenTelemetry? Now, OpenTelemetry is a few things that I believe are important. First and foremost, it is a protocol. It is a protocol and data format of how do we get data out of our application and push it to a backend for us to be able to analyze it. We call this the OpenTelemetry protocol, or OTLP, not the OpenTelemetry line protocol. That was a mistake by one person in one article that has become canon now. But apparently, no. The line part of OTLP was never a thing. But it's the OpenTelemetry protocol, and it's a format of how we send signal data. How we send logs, metrics, traces, profiles, RUM, events. How do we send that data in a standardized format to our backends? The reason why that's important is because now all of a sudden we can decide where we're going to send our data without making massive changes to our applications, which makes it incredibly useful. The other thing we provide is SDKs for 11 different languages. And that allows you to be able to have your application be completely agnostic of the provider that you're using to visualize that telemetry data, which means that you can spend more time instrumenting your applications, being intentional about what's included in that telemetry data, without fear that at some point you're going to move provider and now obviously you're going to redevelop your applications and redevelop all your telemetry. The third thing is something called the semantic conventions. Now, semantic conventions are names, because we all know one of the hardest things in computer science is naming things. So what we have is an entire group of committees that spend way too much time thinking about naming and thinking about the things that we should call. What should we call a HTTP request? Should it be http.request? Should it be http_request? http.request.url? And they spent ages doing it. It's fascinating. It's really not. But they've come up with these ideas of names. And what that means is that if you've got an SDK in Java for Spring, if you've got an SDK in .NET for ASP.NET Core, if you've got an SDK for Python for Flask, an inbound HTTP request will look exactly the same in your telemetry data. It'll say that it's Python, it'll say that it's .NET, but it'll look the same. The reason why that's important is because now the back ends of your data, the things you use to analyze, can make assumptions about the data that comes out. They know that if it's got http.request.url on there, that's a HTTP request that's going out. Couple that with a span kind, we know that that's what it is. Same with log data. If it says k8s.pod.name, we know that's the Kubernetes pod that served that request. Those are incredibly important. Those three things together are what make OpenTelemetry so useful. Now, the fourth thing that we produce is something called the OpenTelemetry collector, which is a processing proxy that takes OpenTelemetry data. It also takes OTL, it also takes Jaeger data, the Thrift protocol. It takes loads of different protocol data and allows you to output it in loads of different protocol data. But it also allows you to do a load of stuff in the middle, and I'll come on to some of the important stuff that does at the end. Now, there are three core signals that are part of OpenTelemetry right now. These are the stable signals in OpenTelemetry. Now, notice that signals is not spelled P-I-L-L-A-R. There are no pillars in OpenTelemetry. Anybody who says there are none. But what they are signals. They're different types of data that you can use in different scenarios, depending on what you're doing. The reason why they're not pillars is because you don't need all three of them to achieve observability. If you can understand what's going on inside of your systems from just one signal, just use one signal. If you can understand it all from metrics, just use metrics. It's so cheap. Pillars implies that you need all of them, you don't. So let's talk a little bit about the signals. So let's talk about tracing first. Tracing is primarily about debugging. It's about understanding the flow that a request, or whether it's a request or a message or some kind of initiating action, what's the path that took through your entire system? You're thinking about things from a user or an initiator's perspective, because that's what's important. Users don't use applications. They don't use services. They use systems that can be made up by one service or multiple services, but a user uses the entire system. And that's what tracing provides us, that view of that entire system rather than the view of an individual service. They allow us to look at these complex distributed systems, whether it's event-driven architectures or distributed monoliths or modular monoliths, whatever term you want to come up with, which is a new hotness. I don't know, modular microservice monoliths, I don't know, something new. There you go. So I guarantee there'll be a talk on that next year. But it allows you to be able to understand what's going on in these complex systems. one of the key aspects of tracing is the idea of what we call causality. It allows us to say that this thing called this other service, which is different to the way that logs and correlation would work. They do have an emphasis on performance, because we'll come on to what the data is in a minute. But the other thing that they have an emphasis on is something called high cardinality and high dimensionality. Now, high dimensionality is the number of additional bits, a number of additional attributes that you would provide. Different bits of context. Things like user agent, source IP address, tenant ID, the settings pack that they use, the language pack. Additional things that come through. The more context, the more dimensionality, the more attributes. Cardinality is for each one of those attributes, how many possible values are there? Low cardinality data has a small bounded set of data, like HTTP method. Bounded. You're generally going to have, most people just use put, get, and post. Occasionally head and options. So you got 5. Small, low cardinality data. IP address, that's big. That's a large amount of data, high cardinality data. User IDs, order IDs. Those are high cardinality data. That's the emphasis of tracing data, is make it wide, add as much context as you can. What I always say is, if it's not PII data, when you're writing your application, if it's not PII, put it as a dimension. The more dimensions, the better. Now, a trace isn't actually something we create. We don't say var trace equals new trace in your application. What we do is we create spans. If we've got loads of spans with the same trace ID on them, that's a trace. But ultimately, a span is just a structured blob of data with some mandatory attributes. It has a unique ID, we call it a span ID. It has a correlation ID, which we call trace ID. It has, crucially, a start time and an end time. The end time there is quite important because we can't emit a span until it has finished. We don't emit a start and then emit an end. We only emit it when it's ended. That is a limitation of tracing data. But the thing that makes them really, really unique is what we call the causality ID. The causality ID is the ID of the span that was active when this new span was created. That's what allows us to build these fancy waterfall diagrams that you see here. We call these trace waterfalls, which allows you to see this idea of how did something transition through my system. Now, the reason why that's important is because on a log, if you're looking at log correlation, the only thing that you've got to go on in terms of ordering is timestamps of your logs. So show of hands, how many people in the room in the last month have checked the time servers on all of their systems to make sure that they're 100% in sync to the millisecond? Yeah, I thought so. When we're talking about requests that finish in 200 milliseconds, milliseconds become important when you're looking at ordering. With tracing, we've got that inbuilt idea of correlation, that inbuilt idea of causality that allows us to know that this system called this system and it happened in this order. And finally, they have this idea of attributes, a bucket of key value pairs that you can just send a ton of data into. By default in OpenTelemetry, the limit is 128. Some providers have much, much smaller limits. Some providers don't care. But by default, the limit is 128, and you'll generally get an exception in your code that says you're adding more unless you up the limit. But add more data. Essentially, they're just really fancy logs. And, they're just structured data. They're just a structured bit of log with some mandatory attributes. I didn't go through all the mandatory attributes there. Those are the important ones. But that's all they are, is fancy logs. So what is a log then? Well, logs are point-in-time data, time-stamped events that happen inside of your system. But ultimately, they're designed for humans. That was the original reason why logs existed. What we tried to do is take logs and provide a format and extract some attributes at source. Go back to the ELK days, the Logstash days. You had a big string, and you'd use some really, really fancy regex called grok to build this big, massive regex string that would extract data and kind of try and give it some additional properties. Now, I stay away from the idea of structured, because it's not really structures, it's just formatted with some data properties. Structure implies that every log will have the same data, the same attributes, with the same names. Generally, they don't. Fun fact, if you want to reduce your logging volume, send it through the OTel collector and put a filter for here, and here too, and also here, and this shouldn't happen. I guarantee you'll save a ton of data. But they're really, really useful for things like startup crashes, because a human is going to look at it and say, why did that pod keep failing? Why did that application not start up? And you're going to log onto the server and you're going to go, why did this not happen? They're also really good at working out whether your tracing's working or not. I mean, logs are fine, I suppose. The reason I love that is if you look closely at what's on fire, it makes more sense. So the third important signal would be metrics. Now, there are two different types of metric. Big M metrics and little m metrics. Little m metrics, dictionary definition, something we measure, a graph that we build to measure something. Those are little m metrics. What most people talk about when they say metric, they mean big M metrics, which is time series aggregations, which is a data point with some attributes, with a timestamp and a granularity. So at 10 seconds past 11 in the morning, for a period of 1 minute, there were this many requests with this average response time with these attributes. That's what people mean when they talk about metrics. Metrics are not the only thing that you can use to build a graph, to build a metric or something that you measure. A lot of systems, it is the only way you can do that, but don't believe that that is the only thing that you have to use to build a graph. You can build graphs like we saw on Kibana. You can build graphs from raw logging data. You can build it from raw tracing data, depending on the backend system that you're using. Metrics, as we talk about them in these kind of worlds, what we're talking about is a time series aggregation that's stored in a time series specific database. So Thanos, Mimr, Chronosphere, they have that M3 stuff that they do. You know, those ideas of using metrics data stores. That's what we mean by metrics. Now, they're incredibly cheap to store because we're storing a number with a few different bits of context. The biggest problem with them is that they lack deep context. They lack the idea that you can get down to an individual request and see what's happening in that individual request. We have this idea of what's called exemplars, which not completely ratified and in all the SDKs yet, but they do provide an example that goes with a data point. It's not the same as being able to see the raw data, but they can get you a little bit closer. But they lack that deep context because they're built for low cardinality and low dimensionality data. Now, people over the years have tried to put the source IP address on metrics. People do it once, maybe twice. And then what happens is you sit and you watch Prometheus in the corner going, please stop. It's not a slight on metrics databases, it's just they're not built for it because of the way that they store data isn't built for high dimensionality and high cardinality data. They're built for that low cardinality data. They're incredibly good at it. Like I said before, if you can debug your systems with pure metric data, it's the cheapest format of telemetry, and you should just use that. It's when you need other things, when you have to ask other questions about your production system that you need to look at different signal data. Okay, so that's the signals. Now, the real magic around telemetry, and not OpenTelemetry, the real magic around telemetry is something called propagation. Now, propagation isn't actually an OpenTelemetry thing. Propagation is this idea of how do we correlate a request that happened in one system to the same request in another system. Now, it's not a new concept. People will have, over the years, added X-correlation-ID and added an ID in one system and then extracted that in another system. There have been various different attempts, so B3 and Thrift, different ideas about how we build these correlations between these systems. But ultimately, what happened was the W3C, the World Wide Web Consortium, came up with a standard called trace context. So now, everybody just uses that. It's not part of OpenTelemetry. OpenTelemetry leverages it. So by default, when you use OpenTelemetry's SDKs and that kind of thing, we use the W3C trace context, which means you've got interop between all of the systems, all the different SDKs. But what it does is it defines a few things, which means that when we go between systems, it's not just a correlation ID that we see. We do see the trace ID, our correlation ID, but we also see the parent span from that source system. So imagine that somebody hits your checkout and the checkout calls your stock API to check the stock before it allows you to order something. What we do is we add on the span that was active in the checkout system so that when you go into your stock system, we can say, and our parent span was this, which allows us to build this big distributed trace waterfall that tells us how things are going on. It does also provide something called sampling, which tells us whether we're going to keep this whole trace or discard this whole trace. I'll come on to sampling at the end. Now, the other thing it provides is something called baggage. Baggage is my favorite thing to talk about. I hate baggage with a passion of 1,000 suns. Baggage is another W3C concept around propagation. It allows you to provide additional context between your services. So you can say, this particular user group is a VIP user group, and you can do something with your telemetry. Maybe you want additional telemetry to be generated in one of your backend systems. It is not multi-span attributes. You don't add something in your checkout service as baggage, and then all of your spans in your stock service then get those attributes on their spans. You can make it do that, but that is not what it is built for. It is, however, incredibly dangerous. Now, the reason it's dangerous is because it's so simple to use. It's basically a string name and a string value. The APIs to use it are incredibly simple, baggage.current.setBaggage with a name. And what we have is a lot of people who go, oh, well, that's great. So I need my user ID in my stock service. Now, I could go and change the API contracts, but I'm not going to do that. I'll just add it to baggage. And then I'll extract it on the other end. And now I've got my user ID. And the problem is that there is nothing in your checkout service that knows the endpoints that it hits, whether they're internal endpoints or external endpoints. It's probably fine to send the user ID to all your internal endpoints. It might even be fine to send it to the external endpoints until somebody says, do you know that the user ID is actually their social security number? And then the checkout service actually needs to then check the exchange rate. So it calls the third-party exchange rate service. And now the third-party exchange rate service has now got the social security numbers of every single person who has added an order to your system. Now, fun story, we got an issue in on the OpenTelemetry.net repo where somebody went, you've broken my system with the update to baggage. We did a small update. It shouldn't have been breaking changes to anybody, but yeah. And they came in and said, you've broken my system. My authentication is broken. And we were on the call and we're like, I don't know how. Like, how on earth could we have broken this person's? So they explained the issue, said, well, what happens is they come into my checkout service and they authenticate with JWT tokens. And then what I do is I take the JWT token and I add that to my baggage. And then I extract the JWT token in my stock service to do authentication. And I think the entire room on that Zoom call was just like, just no. Walk away from the computer. That's the reason it is bad, because people don't understand that baggage isn't internal. Baggage goes everywhere. be very, very cautious. There are ways and means that you can use it. I have some YouTubes on exactly how to restrict this and blog posts on how to restrict it. You can use it. You can use it safely. It's powerful if you use it right. But be careful. If you see somebody using it, really, really scrutinize what they're using it for. So how does it all work? So we have something called auto-instrumentation, or what's now been referred to as zero-code instrumentation. This is essentially codeless. We use environment variables to inject things into your applications. It sideloads a bit of stuff in there, and it's really, really useful for getting started. Now, if you're used to a kind of APM world, where you install an agent from a vendor next to your application, and they give you a load of default metrics and default traces and default logs, that's really what the codeless instrumentation is all about, to replicate that same scenario. That gets you to a point of APM equivalency, but it's not where you should stop. This is step one. It's getting started and get you an idea of what data you can get. It's incredibly easy. This is the .NET one. A couple of bits of bash, download a thing. It'll add some stuff into your startups for .NET. It's really, really easy. It's also really good when you are in a distributed system and you run one service and somebody else runs 10 other services and they don't want to start putting tracing in yet. You go, fine, I'll do things properly and I'll do the coded instrumentation, which we'll come on to. But you just add the auto-instrumentation. And then you can still get that big distributed stuff. Your stuff will be really, really wide with loads of intentional data on it. Their stuff will be quite shallow, but you'll still be able to see where you live in that context. It's a really, really good thing to just get started with. Fire that over to an SRE team or a platform engineering team and say, can we have this? As they're in the auto-instrumentation or the zero-code instrumentation across however many different languages. I think it's not all the languages, but anything that's interpreted and anything that uses like a CLR or a JVM, those ones allow it. But what you should be trying to get to is coded instrumentation. Now, I'm not talking about manual instrumentation. I'm not talking about the idea that you're going to create all your own spans, write all your own metrics. We're talking about coded instrumentation to add the same packages that zero-code instrumentation does. In .NET, it's about 10 lines of code that you add into your startup. And it allows you to be really, really targeted about which libraries you want to instrument. It's not just going to go and instrument the entire thing. You might say, I don't really care about SQL calls, because it's just a database. That's the DBA's job. I don't care about databases. That's why we hire Dave. But it might be that you don't care about databases. It might be that you don't care about your service bus, or your RabbitMQ, or your SQS. You don't really care about those things. You can be a lot more targeted about what you do. It gives you that full control over what should be included in those things. But most importantly, it allows you to be intentional. Because when you get to this coded idea and you've started putting code inside your application, that's when you can start to get to a point of saying, I'm going to add some attributes. Because no amount of APM solution is going to know that X-tenant-number is the number of the tenant, and that's really important. They're not going to pull that in and add that to all of your spans so that you can then use that to segment your data. They're not going to know that you're an e-com site and product ID is really, really important when you're looking at that aggregate data. That's where coded instrumentation comes in. You can use, obviously, the APM style approach to be able to say, just add a load of defaults for me. But then you move on to this coded instrumentation. And that's what OpenTelemetry provides, because if it's in your SDKs and you don't need to worry about whether you come into Honeycomb or Datadog or New Relic, you can spend a ton of time making all of this intentional and not worrying about the fact of which SDK am I going to use. I can just use OpenTelemetry and decide later. Now, we also have something called the OpenTelemetry collector. The OpenTelemetry collector is a proxy. It takes data from your services, from your infrastructure, whether that's logs, metrics, trace data. It takes all of that data and allows you to be able to then output it to various different data stores. You can duplicate the data. You can filter the data. There's a few things that are really important about it. The first one is configuration and the centralization of that configuration. So if you're using a third party, you've probably got an API key. And everybody rotates all of their API keys for their third parties every 60 days, yeah? 100%, yeah. Everybody with their hands up, yeah. If you've got 1,500 microservices and you've got that API key on 1,500 microservices and you've got to rotate that every 60 days, that's hard. What the collector allows you to do is put one in a particular location, have all of your applications forward to that inside your network. You don't need an API key. And then your only thing that you need to change is your collectors. Really, really important. It also allows you to be able to have a central point where you can dual send data. You can say, I'm going to send all of my tracing data to these 3 places. I'm going to send it to a compliance data store, an audit data store, and a production debugging data store. It also allows us to do things like securing egress. If you're running in zero trust networking scenarios, if you go to your security team and say, we've got this new observability provider, and what we need you to do is open up the internet for all of these services. It's like, great, okay, which IP address? It's 0.0.0.0/0. And before you leave the room with the security team laughing, what you should say is, well, what about if I have one pod and I just want that one pod to be able to access this external service? And they go, oh, I'm listening. But you can still send anything you want through there. And you go, well, what about if I let you control the data that can go through it? So we'll send all of our data to it, and you can redact any data that you don't want to go through. You can filter data that you don't want to go through. But you can also enrich the data with interesting context, like, oh, this was running in EU West 1, and this one was running in US East 1. This one was running in this Kubernetes cluster. So your applications don't need to worry about that sort of stuff. Lots of different ways that you can do it. Obviously, you can go direct. It's really good for getting started. Probably wouldn't do that long term. You can start to have this idea of an agent model where you sidecar a collector. Useful for things like Ruby, where there's no async background stuff, so you want to get things out of your application really, really quickly. You can start to move into load balancing. The biggest one I've seen of these is 7 tiers of OpenTelemetry collector, where one collector forwards to another collector, forwards to another collector. Don't do that. They're one of the biggest retailers in the world, and they need it. You're probably not one of the biggest retailers in the world, I'm sorry. Final thing, which we can do in 3 minutes, because it's the most complicated concept in OpenTelemetry, so 3 minutes. Sampling. Sampling is what allows us to be able to reduce our data volumes while keeping context. Now, I normally use a particular analogy, but current political environment won't allow me to use that analogy. I'm sorry, but come to me afterwards and we'll maybe talk about it. But ultimately, what it allows us to do is be able to keep certain data, but extrapolate what the end result might look like. It allows us to be able to say, let's keep 1 in 1,000 of these requests, but say there were 1,000 of them. We can do it in 2 ways. We can do it head sampling, which happens inside of our application. We can do it with tail sampling, which happens outside of our application. And I'll talk about those too, and why they're important. But what they both allow us to do is be able to retain the full context of a trace, including any logs that were part of that, which allows us to be able to reduce the storage cost on our back end, reduce the ingress and egress costs associated with sending that telemetry data. And obviously then, because we've got fewer data points to be able to query, it allows us to be able to query things quicker. Head sampling happens before the first span is created in your application, right at the start, which means it allows you to remove all the performance overhead of your application. Because if you're going to say, I'm not going to record anything for this request, then we don't need to have any allocations for spans, any allocations for logs. No reason to. But it has limited information. If this is a HTTP request, the only information that you've got to hand is the HTTP request inbound data, maybe the URL, the method, the user agent. You don't know whether this is going to error. You don't know whether this is going to be slow. Because if you knew it was going to error, you'd have probably fixed it. So it has limitations. Tail sampling gets around this, because tail sampling runs as part of the collector, and it runs on a delay after the first span for an individual trace has been received. So we have access to all the span data for all of the spans. So we know how long the span is. What's the duration of this request? So we can say, keep everything that's over 2 seconds. But if it's for the home page and it responds in 10 milliseconds, then just keep 1 in 10,000 of them. I don't really care about them. Nobody asks you to look at why a request was too fast. I mean, I hope so, but stranger things have happened, I'm sure. But there are limitations to this. It delays sending your spans to the back end, because obviously you've got to wait for a period of time before you can send the whole trace data on, which means that you've got to buffer that data, which means that you need something that's high memory to be able to store this data, to be able to do all of this. But it also requires all of your applications to spend all of their span data to that back end. Now, if you're running in a multi-AZ environment and you're running in AWS, that can get expensive because AWS see cross-AZ data transfer as a revenue stream, and a big one. If you're using Azure or GCP, you're not so much. GCP you still charge, but it's really cheap. Azure have just said, no, we're not going to do that anymore. So just look at this and what you're doing. So last thing about what's coming, we're getting more and more semantic conventions signed off. So those names that we were talking about at the start, there's more and more different systems and different mechanisms that are being signed off. Databases and messaging will be the two that are hopefully coming in the new year. And apparently people wanted Gen AI, so there's a Gen AI convention coming out next year as well. But those are coming out next year. We've got more and more libraries that are coming up. So whether you're using, I don't know, a particular Postgres library for Scala or something like that, all of these libraries are starting to add OpenTelemetry now. There's more and more coming out every day. We're working on documentation. We hear people tell us that it's hard to understand, which is why I come and do these talks to try and explain things to people. We're working on the documentation. We have an entire team of people. But ultimately, we need to know from you. We need you to be telling us, whether it's coming on the GitHub repos or just accosting me at the when I'm at the coffee cart over there. But tell us what it is that you're looking for. Tell us what it is that's blocking you from moving to OpenTelemetry, or what's making you second guess moving to OpenTelemetry. Tell us what it is, because we don't know. Without you telling us, we don't know. I would be remiss if I didn't mention my company. They pay for me to be here to hopefully give you some inspirational stuff. We are a backend for OpenTelemetry, so you can use all those OpenTelemetry SDKs. You can send the data to us. You can sign up, no credit card, just literally a sign in, and you can send us 20 million spans, log lines, metric data points every month for free. Without even providing a credit card. And we literally wrote the book on observability engineering. It's free on our website. You can go and download it. And there'll be a new one coming out hopefully next year. 2 minutes over, I'm sorry. Luckily there's nobody else coming on, so that's good. But I'm around for questions. I will be here for today and tomorrow, so please come and talk to me. I don't bite, honest. Thank you very much.